Striatus, an innovative 3D printed masonry bridge, recently opened to the public as part of the Venice Architecture Biennale. The 16 by 12 meter or 52 by 40 foot bridge was designed by the Block Research Group at ETH Zurich, the Computation and Design Group at Zaha Hadid Architects, Incremental 3D, and Wholesome. A basic 2D form was decided on, and the bridge was extruded and analyzed in 3D modeling software. Thrust network analyses created force diagrams for every design iteration. At the ideal curvature and extrusion of 2 meters, balustrades or railings were designed 3 meters high. A stereotomy mesh divided up the bridge into 53 voussoirs or wedge-shaped blocks. Advanced discrete element analysis calculated the structural load at different points in the bridge and the effect they would have. Excess load can cause structural failure, so this was considered and controlled by the design of the bridge. The bifurcating decks and balustrades transfer loads to the 5 steel footings or base supports. Since these footings want to move outward and flatten the bridge, underground steel tension ties were added. These pull the footings together, absorb the horizontal thrust of the arches, and keep the bridge intact. Once the design was optimized and finalized, each of the 53 blocks was sliced in non-parallel layers that are orthogonal to the dominant flow of forces. This avoids delamination between the print layers as they are held together in compression. As a whole, the bridge behaves as a series of leaning voussoir arches, similar to a Roman arch. During construction, arches are supported by a temporary wooden frame. Wedges are stacked around the frame until the central keystone is placed at the top of the arch. The keystone bears almost no weight. It is the center of directing the weight of the structure down and outwards. This is called compressive stress because the pressure of the weight is compressed by the shape of the arch. Once the rest of the pieces are in place, the formwork can be removed and the arch remains standing. In addition to behaving like a Roman arch, the Striatus bridge also behaves like a Nubian vault, an ancient architectural technique that uses earth or adobe and mortar to create vaulted structures. Unlike typical 3D printing, which extrudes material in simple horizontal layers, Striatus uses a 2-component concrete ink with corresponding printing head and pumping arrangement. Each of the blocks was printed in non-uniform, non-parallel layers via a 6-axis, multi-DOF or degrees of freedom robotic arm. This new generation of 3D concrete printing allows the forms to be used structurally without any reinforcement or post-tensioning. Compared to conventional concrete construction, where beams and floor slabs are solid, heavy blocks, the bridge uses just 30% of the total volume of concrete and 10% of steel. Strength is achieved through geometry rather than mass. Every section of the bridge is hollow, thus minimizing material and reducing transportation and labor costs. The forms were printed in Switzerland in an indoor controlled environment. Once cured, they were strapped to pallets and transported to Venice, Italy. A laser-cut OSB formwork was on site ready to receive the 3D printed concrete forms. Once the steel footings and tension ties were in place, a crane carefully lifted the voussoirs. The pieces do not interlock and they are not attached in any way to each other. A neoprene pad is all that separates them. Once all the pieces were in place, the formwork was disassembled. Wooden stairs and a walkway were the last components to be built. The bridge is inspiring for so many reasons. Aesthetically, it is unique, sleek, intriguing, and it works with the surrounding trees and landscape. While it doesn't have a functional purpose in a park, it is experiential art. It also follows the 3 R's that I mentioned in an earlier video: reduce, reuse, and recycle. It uses minimal material with no waste. All the components are designed to be disassembled and reused at another location. It can also be recycled easily because it doesn't use any reinforcement, binders, or glue. I'm always disappointed when companies use 3D printers to build boxes. When you have this incredible technology at hand, you should push its limits and build structures that can't be built with manual labor and traditional methods. This bridge has combined human intellect, machine computing, and the latest technology. The designers looked at historically proven structures like the Roman Arch and Nubian Vault for inspiration and adapted the design to work with today's technology. The companies involved in this project were located in 5 different countries and were working with a very tight schedule and budget. Since traveling was restricted last year, they had to pull this off with just remote communication. It is very impressive. However, there are a few drawbacks. The bridge isn't wheelchair accessible. The designers were probably constrained by the dimensions of the site, and since ramps need a lot more space, they couldn't make it work. Also, since the 53 modules or the wedges are so lightweight and fragile, 3 of them broke during the shipping and installation process. They had to be reprinted in Switzerland, allowed to cure, and shipped separately to Italy. This caused massive delays on site because the bridge is built sequentially. You can't just skip a piece and move on to the next part. The last issue is the clash between the precision of the machines and 3D printers and human inaccuracy. Even though the concrete sections were printed accurately and the formwork was laser cut, the concrete foundations were made by humans and the OSB formwork was assembled by humans. There was a 2 centimeter difference between some of the foundations, so the workers on site had to use a good old-fashioned chainsaw to level it off. All in all, it is a beautiful, inspirational piece of art. I hope it's used as a case study for future 3D printed projects. Let me know what you think about this bridge in the comments below. I'll also link my Patreon page in the description. If you can support me, I'd really appreciate it. A big thank you to everyone already supporting me. Don't forget to hit the like button and subscribe to my channel. Thanks for watching. See ya.